Hello, welcome back. I'm Ren, technical designer at UX is Fine, and today we're going to be creating a Bezier curve across the screen for a sort of card game. Just another technical UI challenge, like how would I solve this? So we'll take a look into how I approach solving that problem. I don't have connection to the YouTube chat today. No YouTube event detected. Please check your YouTube dashboard. The stream is there. I can see the stream. The stream is live. I am live. There is one person watching over there, but I can't see the chat, which sucks. So, unfortunately, I will just have to pretend that no one is talking on YouTube because I can't seem to fix it. There doesn't seem to be a way to refresh my UI for the chat. So we're just going to crack on. We're gonna do this. Maybe we'll try and do it fast. Okay. So the first thing, as always, let's create a new folder, episode 11. And actually, let's take a look at the reference imagery as well. I'm just going to open up the reference, planning, my planning thing. So we have this. If I hit play on this GIF, you'll see this arrow as this person pulls this card from their hand over to the game and it hits an enemy. There's other things that happen, like turning your card into a creature, which is cool. But there's some stuff going on here. There's firstly, there's a glow around the card. The card is moving gently with the mouse movements, X and Y. You can sort of see a little lerp movement there, soft movement. You can see as he drops the card, you get this cool effect over the card. We might do some of these other things. There's a lot of cool stuff that I could learn and we could learn from doing this, or we could, maybe I already know how to do it, but we will try making it. So that line in particular, I want to do that, and what it looks like to me is a Bezier curve. So what I've done is I've gone over to GPT here and I've said in UE5 blueprint, I have a number of dots, let's say 14, that I want to position on a Bezier curve, and the curve starts at an origin canvas position when I click the mouse. And when moving my mouse from left to right and up the screen, the dots move with the curve, and it should have some configs to manipulate how the curve behaves, such as a float that makes the arc taller, or one for making the Bezier, the arc wider. And it's given me an overview. It said, okay, I understand what you would like. This is the typical Bezier curve formula. And in Blueprint, what you'll need is your dots, you'll need your start and end position, you'll need some arc height and width as variables. As far as I understand, I actually need 3 points for a quadratic Bezier. I need a start point, control point, and an end point. Now this, oops, what did I just do? This control point possibly will be creating through the widget. And then we do some lerping, apparently, for each point. So we go through each point, we get the time across, so the index of the point divided by the number of points. And that's going to give us an alpha from 0 to 1. And then our position is just along this, essentially along this Bezier curve. Where should I be? And then we just set the render translation. And then we'll work with the angle and things like that, maybe some scaling. We'll do a bunch of other stuff. But this is the crux of the calculation, which thanks ChatGPT, will get me started nicely. So we have this black scene, this basic scene. Let's create a user widget, which will just be our, we'll start with an overlay. Actually, we're going to end up being a canvas, but actually, is canvas an option? Widget. I'm going to go user widget. Is canvas an option? Canvas panel. Cool. Widget underscore, and we'll call this Bezier dots, I guess. Pop this open. We've got a canvas panel here, and we need at least three. We need at least 3 control points. So we will start with that. That's what I wonder if we can get like a target. Yeah, so we'll use this target here. We'll say 64 by 64. And we'll just move that into our scene. So that'll be our first point, second point, third point, and we'll pretend that this is like start position, control point, end position. So we'll have start, control, and end. We're controlling end here, so let's say the end is over here. The start is usually somewhere in the middle at the bottom, like a card. And the control point will just put, I'll put it on the left if your mouse is on the right, and I'll put it on the right if your mouse is on the left, and that way the curve will aim towards this, but in relation to this end point, so we'll get this nice curve. So for now, we'll go to the right. And then I need to draw a number of points along this. So let's just find something that we could use as a dot. We'll use this sphere trigger texture, I suppose, at 64 by 64. That might be a nice test one. We've also got what look like a dot there. Dot. Do we have just a dot? Do we have a circle? I have some stuff lying around that will work. Let's just get into our graph, I think. So for anyone joining, I apparently just can't see the chat. Oh, the chat has connected now. Can I get some I? Can I get some ones? Can I get some highs? Can I get something? I want to know if I can see the chat. I see that there's a couple of people here. Welcome. We're building the Bezier curve from Monster Train, essentially. That's sort of the long and short of it. It's going to be pretty simple. It's this curve here. I'm going to build this today. But I am under the understanding that my chat is a little bit iffy today, so well, we'll see. So my cat is complaining. Okay, so moving on. We have this canvas panel. We do want to work with this canvas panel. We have it as a variable. Let's draw the dots. So let's do a for loop. And let's have a property here. It's just num. I guess num points would do better. Or num dots. We're going with the wording dots. So we're putting dots everywhere, so that's fine. -1 on this. Okay. We're going to need an array of widgets. Dots, we'll call it dots. It's an array of user widgets. What we'll do here is we'll remove these from parent anytime that we draw the dots. So we'll do that on every entry in the array. So it's a nice little thing that you can do there with arrays. And we're going to move this over and just get started drawing each one of these dots through this for loop. So every time we go through this execution chain, we'll create a widget, and that will be our dot widget, which we need to actually create as another widget. So here we'll have an overlay widget underscore dot, and we'll call it Bezier dot, I suppose. And in here, if we go to desired in the top right, so you have different sizes, you can do custom, you can test how something looks. Portrait, ultra wide. In our case, I want to use desired to see how big it is if it's unconstrained. Use an image. It's going to be a sphere. It's going to be the sphere here. We'll go 64 by 64. Okay, so that'll be our widget. That's fine. So we'll get dot, Bezier dot. We'll add this to our canvas, add child to canvas. And I think for now, for visualization purposes, we'll get the start point, we'll get the position, or we'll get the canvas. Okay, we'll get slot as canvas. Doesn't want us to do any of those things. Slot as canvas, thank you. I love that get isn't in here, even though we are getting a variable. So we get the start point, which we've seen is like we have 3 points to control a Bezier curve where we'll draw a bunch of dots around here. If we get the start point here, it has a position on the canvas from the top left. So if you imagine this is our full screen, 0, 0 at the top left, 1920 by 1080 or whatever your resolution is, this position here is the important factor right now. So we get the position. That's super handy. And we're going to use that to set the position, of this asset that we've just created, a new Bezier dot. We can just refresh the nodes here, compile this, right? And then we're going to add, for now, I'm just going to add upwards of that point by a multiplier, just for visualization. So if I multiply this by, say, 50 units, we'll see, in fact, we'll see this move positively in the Y, which if I was to add 50 to this unit, we can actually test what that would do by just adding 50 here. You can see it actually goes down the screen, because if you think of it as 0, 0 at the top left, adding to the Y goes downwards, and minusing from the Y gets closer to 0 at the top. So when we're testing this, we need to multiply this by -1 as well. Oh, not -10, -1. And there's two ways you could do that. You could do that by adding another multiplier, or you could just say multiply by -50. And we're not adding anything to the X here. So we have a bunch of dots that we've drawn and we've set their position. And to test how that looks, we can just drag that into our pre-construct. Designer, compile. We do get some dots here. However, what it looks like is they're all in the same position. And one of the reasons is because we only drew one dot. So if we draw, say, 14 dots, now we have 14, but we can see that they're squashed, right? And so if I was to just drag an image in, we can learn what the behavior of Unreal is. You can see here, it comes in natively at some scale. You can see it's kind of the same scale. So what we haven't done is we haven't set auto size on our widget, and also it's anchored from its top left. So if I was to rotate this, well, in this case, actually, it's anchored from its center, which is convenient. Usually there's an alignment here, you see, you can play with this alignment. So we need to do that on all of these programmatically. So we come in here and we can say, set the alignment of this to 0.5, 0.5. Set the anchor is fine. Set the auto size property to true. So for each one of these that I am creating, I want to do this. Now we have dots. We never added to this. So let's make sure that we're adding these elements to our dots list. And that's so that we can reference them and manage them in various ways later. We've got a little variable that holds all the dots. We're removing all dots from the parent at the start, and we should also clear that array anytime that we draw dots, which should only be once, but when we're on pre-construct, it happens frequently. So just to bear in mind, this pre-construct runs anytime that you look at it in the viewport here. It runs anytime you're in here and you're changing variables in anything. Anyway, so now we have our 14 dots moving upwards. Now we just need to control them based off of the math. And the math we have derived from anyone who wasn't here earlier. We asked ChatGPT this little prompt, which is going to give us a controllable Bezier curve in Unreal Engine. Tells us the math for Bezier curve with t as a time, which is an alpha of the number of dots. A couple of variables that we'll need, and then we've got the control points and logic here, and this is the for loop that we do to actually update the dots. So let's get that going. Let's actually see if we can do that real quickly here. So functions, update dot positions. For each dot, let's just start writing out the math. For each dot, t is equal to index divided by total dots, which I need to convert to a float here. And so we get the length of this. So this is t, time across the line, essentially. We'll promote this to a local variable here. We'll just call it t. No point in making it any more complex than the actual formula. So that's time. Position is equal to, this is going to start being fun, position. So vector 2. Make vector 2d. Promote this to a local variable. L position. Position is equal to 1 minus t. So we get a minus in here. Pull this down. 1 minus t to the power of 2. Not squared. Squared. The power of 2 of that. Multiplied by 0.0. P0. What's P0? This is where I'm starting to be like, what is P0? I guess it's the position of start. So slot canvas. I might be completely wrong, but we'll try this. Get position multiplied by this. So now we have a vector 2. And then plus a multiplication, which is a float in this case, of 2 multiplied by 1 minus t again. I don't know which. Okay, I'm going to ask it to put this in order or brackets. Yeah, so the formula, obviously we have the bidmus, so like, or whatever it's called. So multiplications and additions and subtractions are going to happen in different orders. And so because I just have a straight line, you can see it here, because I just have a straight line and I'm trying to write that in here, it's not going to be great. In fact, what I could do though, is I could just make a math node, a math expression, and I could literally just put this into the math expression. And now I have now I have the 3 points. That would have been the significantly easier option. So we'll go with that. How do you straighten the connections? Reaper, hey, how's it doing? How's it doing? How's it going? How do I straighten the connections? At the moment, I've just drawn a bunch of points in a line on construction script, and I've just added the index of the points. So 1, 2, 3, 4 multiplied by minus 50. So minus 50 minus 100 minus 150 to the y to set the position. And that's just for previs, right? I can see now I have 15 points. The next thing to curve it across the asset is this update dot position, which is this nice function that I've just made. I want these to all be vector 2Ds, which I just messed up. Okay, that. There's no return, which I find really strange. And also it's broken. Why is math expression not working? UE5 math expression, no return. So it's got all this logic here, but it's really messed it up. So that's a shame. I just make a new math expression, and this time, if I paste it in, take a look inside, we have all the logic in here, and we have this. We have these. These don't go anywhere. They don't output. That's so annoying. Um, this isn't working in the math expression node, is what I'm going to say to GPT. How do I straighten the connections between the nodes? I'm not sure yet. We'll solve the problems as we come across them. Step-by-step Bezier implementation in Blueprint, no math expression node. Yeah, fair. Fair. Let's do it manually. 1 minus t, yeah, we're using that a few times. We've got float A, which is 1 minus t squared. We've got float B, which is 2 multiplied by 1 minus t multiplied by t. Find that interesting. Okay. That should be fine. Maybe. 2 times this times this. It's displayed over here as 2 times this multiplied by this, which I'm reading is 2 times this multiplied again by this, like in order. I think that's how that works. We'll see. And then we've just got t to the power of 2 for the last point. So this is the 3 Bezier node logics that we need. Then we have vector 2D, pat A, pat B, pat C. A multiplied by, yeah, okay. So first logic multiplied by point A, and then we've got start, control, and end. So B multiplied so, and then finally C multiplied like so. Then sum all the results. So that was a lot easier to read when I asked it to break it down. Now that's the summary. And so this should theoretically be the point. So we'll promote this to a local variable L dot, and we'll see how well this works. We will get this L dot and slot as canvas, and we will set position. Plug this in, and we will see what happens if we put this in our event graph after our update positions logic. Go to our designer and press compile. You see we now have the Bezier curve that moves all of our points based on where we put these control nodes. So now it's just a case of controlling these nodes. So it's like how much do you want the Y position of the mouse, and then I'm going to just code a lot of this logic myself now. Now that we have the basic Bezier done, because I can just control these points to lerp even above the mouse position, because this will be the mouse position. One thing that I'd like to do quickly is get these all rotated in order, or optionally rotated in order. So let's make a variable for rotate to, or should rotate. rotate to spline, rotate to curve. I like to get a good variable when I'm doing this stuff. Configs. Compile that. Just take a look in our graph here. Just make sure that configs is a good name. Rotate. Yeah, cool. We'll get num dots. That's also a good config. Dots is probably private with a getter if we want to animate these. So we'll return this. This is a pure const function. Can't be changing variables in there. It's just a getter. Okay, let's put these in the core functionality here, and then the helpers here. Helpers. Cool. So that organizes our stuff. Then we've got logic here. So widgets, do dots. Cool. So that's our class nicely configured. What we were about to do, we were going to rotate the dots. So if the config for rotate to curve is true, then we will grab this and set the angle. We might not need to. Set render angle. Cool. And we'll set it to again, we'll just, instead of doing like a, because what we could do is we can do a find look rotation here from vectors. But there is a logic to just say give a angle rotation formula using two vect 2Ds. Yeah, so give an angle rotation formula, or a angle rotation formula. Funny, it says use the find lookat rotation with start and target. Option 2, manual math, more control, angle. Okay, so the angle is equal to the atan 2, which is what I wanted, of the vector 1x, which will be, yeah, I'm gonna need to promote this array index to a variable. So we'll just call this L index. And so now we can reference that a little later on. So if I say get index -1, that could be -1, right? The first entry we come through, it could be -1. So let's just double check. If we're equal to 0, then we'll do one logic, and otherwise we'll do the other logic. Because if we're 0 and we try to get from this array -1, this will just spit an invalidation error, a null reference exception, or an out of bounds exception. So here what we do, we could just promote this to a variable. Oops, not that kind of variable. We'll call this L angle. Just do this over here. We want to set L angle to an atan. If we're rotating to the curve, and if our index is 0, then we're going to be using one logic. Otherwise, we'll use a different logic, but we'll always call set angle rotation afterwards. We're just setting up the variable for that here. It's down. Call this angle to last point, and we'll call this angle to start location, or start point, I suppose. Say last point is a ambiguous word because it could mean the last in the array, so we'll use previous. It's a little bit more verbose and obvious what the intention is, rather than saying last point. Could be misconstrued. A lot of coding for teams is being a good communicator, right? So as little ambiguity as possible. So we have the dots, we have the index. We can now get the slot position from this. So we're just going to take the same code that we've been using, the canvas slot positions. Whoop. We will get this position and we'll also get our current position. So if we take L dot canvas get position, we can split these. And it's just we're just multiplying some things and minusing them from each other. So first we get vector 1x and vector 2y. Vector 1x, vector 2y. So that's multiplied minus vector 1y multiplied by vector 2x. I should really put this one below. This is the target, this is the origin. So this is, you can see the math here. A tan 2, this is what I'm reproducing now over here. So it's a tan 2 of vector 1, which is current, x multiplied by y, multiplied or minus this one, which is vector 1 y multiplied by vector 2 x. So that's good. And that's our first input. And that will be our x. Take this again, although we may not need to actually duplicate it. But now we can just do vector 1x. It's going to be a similar logic, right? Vector 1x multiplied by vector 2y, I assume? No, vector 1x by 2x. And then vector 1, oh, plus in this case. Interesting. Plus vector 1y multiplied by vector 2y. And that goes in the y. I've realized that's for here. Same logic again, but this time instead of getting this element, we will just get the widget start point here as a canvas position. And we'll plug these in. So this is our x, this is our y. We could now go and wrap everything with our code. So do this. So you can use the find lookout rotation node, but I like math. I like math. There's more things we can do with this. It's good to know math, like when you're working a lot in widgets or 3D vector math for gameplay. Like all these math operations really come in handy, I feel. It takes a little bit longer to write, I'll say that. Okay, so now in our designer, we go and click rotate. We'll get some rotations. We're not getting the right rotations, which is ironic because now that I've just spent all the time doing this, I might need to do it again, although I might have just got the math wrong. A tan 2 degrees here, yeah. Now it's saying, what I could do, actually, is I could promote one of these to a local variable. To clean this graph up a little bit, what I'm going to do, instead of having two near identical math, and having to manage both of them, I've got my dot, which is fine, and then we've got this start dot, and we've also got this dot. So let's recombine this and promote this to a vector, which is L target. And so if we are 0, then we'll use the start point. We don't need this logic now because this reads as it reads. There's no need for the prints now. Although if I was to put a print in here, or say a comment, I would say something like, the reason that we're doing this particular branch here so that we don't access -1. Press R key to create a redirector, and now we're just going to go straight into here. We don't really need to have this angle function. Get rid of the entire box. Come along. Here we have this position and we have the target position. And what we can do is vector2 be this minus vector1, which would be our origin, or it might be the other way around actually. We want to get the direction to us, so if I take my target minus me, I don't know, we'll figure it out. I always forget which way around that logic is. Okie dokie. So moving on, we have get the direction. So this is the direction and a magnitude in this case. The angle is an tan to direction y. Direction x. So that should be cleaner. Let's see how that behaves. So here we have interesting one. And then these are supposed to be pointing at their previous item. We need to change our dot to like an arrow. We'll use this arrow here. 64. Obviously that's not right. So either we're doing our directions wrong, or we're doing our XY here wrong. See how these are flipped? So yeah, I don't think it was the direction. Well, it may have been, but for some reason the tan 2 degrees node is always flipped like that. So now we have this curve. I'm just curious what happens if I use this. I guess it's just going to be 180 the other direction. Sure. We'll add 90 to this, so we actually get the angle that we want. Cool. And what we'll probably do is add a unique endpoint, because I think, or we'll change the logic of the endpoint, maybe in the dots. But we're pretty much there. That's a nice Bezier implementation. The points do get further away towards the end, and if we actually go and look at our reference material, that may be the case. You can actually see that it is. They're closer together at the beginning, they're further away at the end. It's an identical representation in this case of the same logic. I do prefer the idea that we would make this maybe like more uniformly distributed, but I'm not going to worry about it for now. That's something that we can do as polish. What we need to do is get this actually working when we use our mouse in the viewport. This is cool. Oh, I suppose it depends where your control point is actually, which is good. So what I want to do is I want to keep the control point at the same Y as my mouse, because I think that's always going to look good. And always an offset from my mouse, possibly based on the distance of my mouse in the X axis to myself. That could be a curve that we could control. So we basically want to give a designer the controls to say, how do I want this curve to behave in various axes? I want to be able to control because yeah, you could have a Bezier curve that's just a line in which the y-axis is the same. Do you want outcache? Are you asking to go? So we want to give some designer control. I need to fix the bug with the first point because obviously something's going wrong there. This one just A, it's not in the right location, and B, it's not in the right orientation either. Hmm. I guess its position literally is the start position. So what we might want to do is just add, like here, we would just literally add 5 units upwards. Oh, sorry, -5. So we want to go upwards. And that'll give us enough difference between the start point and the asset. Interestingly, we're not starting at the origin of this, but that might just be because these are not set to 0.5, 0.5. So we may as well do that. There we go. This will make more sense now. So that's cool. Like I say, we want to now control the Bezier curve control point. If I was to just leave it in the center, then we'd get a straight line in the middle and a curved line at the outside. And maybe that's actually fine for a first iteration. I don't think we would need to necessarily do anything beyond that because we know we could play with this curve. We don't need to do that to prove the system. We just need to prove the system. And so we want to go back to our producer and we want to say, hey man, I got that cool curve done. And they'll look at it and they'll be like, wow, yeah, it works. That's awesome. And then artists will be like, can we do this? Can we do that? So rather than putting the horse before the cart, or the cart before the horse, as saying maybe, I'm going to leave, or I'm going to set the position of this when we've clicked. So we need so let's get this actually drawn onto our screen. So we have our Bezier dots. In our event graph, I'm going to put this on design time only. I'm going to have a tick event where we update the dot positions, but only if we're active. And actually what we could do is we could just call dot positions because it's just going to go for a for loop of nothing and end in the event that we haven't clicked. And so then we just need a function that's start drag create create curve. Cool. And for this, our input is going to be start location. And so what we can do then is we can get our start point, slot canvas, set position to the start point. We could set our, we're going to do this a few times. We could set our control point to whatever the start position is, get start plus it needs to be above but never below. It needs to be above that point but never below 0. It needs to be just like somewhere above. I guess it needs to be the mouse position technically. So we could just get mouse position in viewport and promote that to a variable to use for the rest of this function as well. So we'll promote this to local variable L mouse. Getting a bunch of pings on my phone right now. Okay, so L mouse got this. Why is it doing it weird? L? Because I didn't use... whatever. L mouse, right. So we could actually set... We could break this. To be fair, the start position is going to be the mouse position. We don't need this. The start position is the mouse position. That's where we're going to be drawing it from, I think. Or at least the top of, say, a card. But in our case, we're going to start from the mouse position and we're just going to drag around the screen. So yeah, I guess. Can I do this? Can I do multiple? I can. I'm just going to set all 3 points into here to start with. And draw, so that's the core, and draw the points. So then we'll just get a bunch of points in the same location. And then as you move your mouse, that's when you'll start getting some sort of elements drawing. What I'm going to do actually in our update positions is I'm going to take the index, L index here. And when we're adding -5 here, I'll just split. I'm going to remove this pin actually. Remove this pin, add, remove this pin, split. Because we might draw a bunch of dots on top of each other, I'm going to add the index, I guess multiplied by -1. So it's further up the screen. I'm going to add them like this. So you actually get points that are all above each other. Apparently that's not enough. So we'll go 4. It does end up brushing them over here. So we could say that this is stronger towards the beginning. I don't know. We'll just do what we did before. It's fine. -5. Maybe I'm just overthinking this. I do want to keep it the same. We're going to have a bunch of points that are on top of each other for a moment. Update dot positions. Obviously, if there's no dots, nothing happens, but we have drawn the dots in this case. And so that's because we've got create curve, and then I guess we've got like destroy curve is just another function, which in this case is going to remove all the dots and clear all the dots. So we could actually, in our draw dots function, get rid of this and replace it with destroy curve. So that will happen when your mouse is released from the viewport. And while your mouse is moving around and we're updating these positions here, I think what we always want to do is, if this is not empty, update the 3 control positions. In fact, we could do that in a separate function. Let's just keep this function for updating the dots based on the positions, and then we'll do update control positions. So if there are points, then we should update our control positions, then update our dot positions. So our control positions, let's take a look at that. In our create curve, we have these set position nodes, event graph, update control here. We've got this, we've got this, get rid of this. We have 3 points and we need to just keep them updated. The start point will never change because we're not going to move that over time. So we can get rid of that one. The control point will be equal to, we get the mouse position in viewport, promote that to the local variable that we wanted earlier, L mouse. One thing to be mindful of is, before I go any further, is when I created the curve, I created a local variable for mouse, but it's not in the local variables. But sometimes if you leave that stuff there, it just gets confusing. So make sure you clean up the local variables as you go, if you're not using them. So get the mouse position, we've got the mouse. We want the end position to be where our mouse is. And we want the control position to be the same as our start position on the X. So we get the position here. So what we're doing is we're saying this control point and this start point here. The control point will be the same x-axis, but the y will always be equal to our end point. And possibly we could give it a modifier to just move it around, which will be fine. So we could say, we break this, we know that we want our control point to always be on the same x, but we want it to be on this y, and we could say plus, and then we could say here, just like, I guess, minus 50, remote to variable, control height modifier. Put that in configs. That will be our control point. So that will happen every frame as we move our mouse around. We could also do it on mouse move, which would be smarter, I suppose. Then mouse move. Do that through here, mouse move. And so I think what we'll do is we'll print string here, hello. And here we'll just say handled. We should probably not handle it. I don't know. I think it handles the move, not all clicks. Not 100% sure. Here we have a details panel. We can now draw our Bezier dots, play. We don't have a mouse, so let's just modify this draw widget blueprint here. Set show mouse cursor to true. Cool. I just wanted to know if it was going to print move whilst I'm, so it's only on the hit testable geometry. So, and in fact, I can at least test my theory, which is if I'm still, it does just tick all the time. So using this move function doesn't guarantee that you haven't moved and calling it less, which was my hope. That it actually only happens when there's a delta, which means I can just use tick, which is fine. Okay. So now the next thing is for this Bezier dots thing. I just need to be able to start and end the event for testing, right? So what I could do is make my canvas panel visible so I can click it, and then in my mouse button down, just get position. We can just do get mouse position viewport in this case. I don't want screen position because it won't respect multiple monitors if I remember correctly. Create curve at this position. And then we have event mouse button up. And all we do is just destroy curve. And here we can just say it's handled. So we get, it's, I did something the wrong way around. Event graph, update control positions. The control point should be the end point. So the mouse's height and the control and the end points, no, and the start point's X, sorry. Start point X, mouse point Y. I did that wrong. And plus control height modifier, which in this case is minus 50. Yeah. So this is cool. This is the monster train kind of like arrow thing, which is pretty cool. And so we are less than an hour, and I think that's a nice place to end a stream. It's a nice quick example of how you could set up um, one of these features for a Bezier curve on your head. And obviously you could start this from when you click on a card, and the start position would be the top of the card instead of your mouse position, all these kinds of little things. But it's functionally ready and capable for that. We can handle this here. Cool. So that is our Bezier curve little session that we did today. Thanks for watching. I hope that was of educational benefit and shows a little bit of the process that I take when I have a challenge, I haven't done it before, and I want to get results quickly. I'll get my formulas from the super Google of GPT, and I'll get the some widgets, some imagery just to represent stuff as I work through the code, and I'll make sure my functions are all commented and categorized and logical for being used in other scenarios. So like, for example, rather than just like, in this case, we used mouse down and up as like a test bed, but like functionally you can call start, you can call end, you can call like various things, you can configure certain things. All this stuff is configurable and callable as functionality. And so that's how I like to script these little features, these little panels that we would make. Is I don't I don't want to think about the business behind how it wants to be begun. I just need to know that it can begin and it can end, and I'm exposing those functionalities to the next person in the team or myself in the future. So it's really clear and obvious when I come back to this code, oh, that's how you start, that's how you end. There's not many functions. And again, we can take a look at that quickly. So like here, we just have categorized our exposed widgets from this graph here. We've got a couple of configs. So when we look at the asset, we can get number of dots. We could increase this. We say, oh, I want 25 dots. We've got the control point modifier. We could say that's minus 200. So now when we hit play, it's like a higher curve. You can see how the control dot is always just slightly above. We've got another config for rotate to curve, so we could actually turn that off. Say, no, I don't want to do that. And let's say that our curve is just, or our arrow is just something. I don't know what. Let's say it's a bunch of money bags. Obviously, yeah. It could be any graphic, right? It's a cool little picture. Yeah. I'm gonna go back to being an arrow. Arrow 64 by 64. And I want it to be rotated to the curve. Hit play. Happy days. Thanks for watching.